New Zealand is a region well known for its geological activity, due to its position between the fault line of the Australian Plate and the Pacific Plate. As a result of this high geological activity, there is a large abundance of volcanoes throughout New Zealand's North Island, with some dormant volcanoes in the South Island. Many of New Zealand's volcanoes are presently active, and the highly active volcanoes are found in the Taupo volcanic zone, such as Mount Ruapehu and White Island. The subduction boundaries of the Pacific and Australian tectonic plates act as subduction zones.
Diverging plates move away from each other, creating gaps in between them where magma rises to fill these empty spaces, eventually leading to an eruption. Subduction, on the other hand, is where an oceanic plate is pushed underneath a continental plate as it is not as buoyant or thick. As it is pushed below, the crust begins to melt the Earth's mantle. Water from the crust is boiled off, causing a chemical reaction that lowers the melting point of the rocks in the solid mantle, forming magma. This magma moves upwards until it eventually erupts at the surface, forming a volcano. This process is what led to the formation of New Zealand's volcanoes such as Ruapehu and Mount Tauera. Any remaining magma that does not erupt idles in the crust, heating it as well as the water within the crust, resulting in geothermal activity in places such as Rotorua and Taupo.
Three forms of volcano can be observed within New Zealand, such as the cone volcano or stratovolcano, caldera volcano, and monogenetic volcanic field. Caldera volcanoes are formed due to violent eruptions that temporarily empty the magma chambers of stratovolcanoes. This rapid emptying causes the cone to collapse due to a lack of structural support that was provided by the magma. The cone proceeds to fall into the magma chamber as pyroclastic flows or as air flows. Caldera volcanoes can also be developed as large sunken areas with a high abundance of geothermal springs or simply as lakes. Both methods of caldera formations share large magma chambers found close to the surface of the crust. Monogenetic volcanic fields are regions of volcanic activity occurring in several short-lived volcanoes within the region. These volcanic fields often have a low supply of newly generated magma, which creates pauses between eruptions over time, and usually means these volcanoes only ever erupt on one occasion and become extinct following the eruption. However, so as long as the magma chamber remains filled with new magma, new volcanoes will be created in spatially new locations each time, as the volcanic fields do not establish a main magma conduit. Stratovolcanoes or cone volcanoes such as Mount Taranaki form due to a large number of intermediate, smaller-sized eruptions with viscous magma rich with silicates. This process of continued small eruptions allows the volcano to build up alternate layers of solidified lava and ash, until a steep cone is developed. Gas tends to be trapped by viscous magma, and pressure builds, eventually leading to a violent, explosive eruption.
One of New Zealand's most prominent eruptions in history. This produced a mass pyroclastic thermonuclear ejecta cloud, almost 6 to 7 miles high, and submerging surrounding biota with 1 meter of the ash. It was caused by the magmatic intrusion due to the accumulation of energy and pressure, breaking through the lithospheric plates. The magmatic intrusions were thought to be 800 to 900 degrees Celsius. Rhyolite is very high in silica content, causing poor flow of lava and frequent explosions with bubbles of gas. This composition would be a strong contributor to the explosive nature of the event. It was so powerful that the P waves were traversing through the rock medium at the speed of sound. The remaining structures include the rhyolitic dome structure as shown.
New Zealand's volcanoes can be directly linked to its position on the Ring of Fire. 75% of the world's active volcanoes are found along the Ring of Fire, which is a 40,000 kilometre belt of volcanic and seismic activity that is caused by tectonic plate boundaries that meet along the belt, which either diverge or subduct.
Since the Australian plate is both higher mafic in composition and density, it subducts beneath the Pacific plate, which is further accelerated by the convection currents and the polarity. As New Zealand is located within the perimeter of the convergent boundary, it leaves all biota susceptible to the effects of the earthquake. According to GNS Science of New Zealand and the European Mediterranean Seismological Centre, the seismic data states that over 15,000 earthquakes are generated every year. As both plates collide, a mass amount of energy is placed onto surrounding rock as compressional stress. As this stress accumulates, the surrounding rock cannot bend or metamorphose within the same rate as energy accumulates. relieving this energy as a reverse fault. The focus of the hypocenter is the main point where the fault has occurred within the lithosphere. Directly above lies the epicenter, where the effects of the fault is felt from the surface.
During the ice ages, the many glaciers in New Zealand gradually moved down the mountainsides. This huge amount of physical force is what carved into the landscape and produced the deep river valleys we see today. With this movement, they produced and carried glacial gravels or outwash, which then formed wide riverbeds and in some cases even produced extensive open plains. Throughout history, earthquakes in New Zealand have been observed to significantly alter the courses of such rivers. Maria Falls on the Maria River in the Buller area is a drastic example